Hey grade 12s, and welcome to this video. In this video, we're going to be working on the functions part of this paper, which is the grade 12 maths paper 1 prelims, but specifically from the Gauteng province. Also, let me just mention that this is a 2023 paper. Okay, so we're on question 4, and question 4 says, consider the graphs of g of x, which is equal to 6 over x plus 3 minus 3 over 2. So please notice that's just a constant, okay? That is just that q value there. That's all it is. Despite the fact that it's a fraction, it's just still a number. And then we have h of x is equal to 6 over x minus 3 plus 2. The first question is to write down the domain of g. So remember, the domain is going to be all your possible x values. You don't have to write down these graphs. I'm just showing you so that you can understand how that works. So we're just going to look at all the possible x values of this graph. Okay, so the graph of g is this one, right? Now, as you can see, you have a normal hyperbola. So in order to actually find out the domain of this graph, this is what we're going to look at. You see a hyperbola. Despite where it is, because a here, right, the value of a, the 6 is greater than 0, your graph is going to lie in your first and your third quadrant. So it's going to look something like this. Now, this graph is going to have every single x value. You will see that it will always have an x value, okay? This is a point, that's its x value. This is another point, that's its x value. It's going to keep having x values all through, except for one place. And the only place it will not have an x value is where it has a vertical asymptote. So it's going to have its vertical asymptote here. And this is how we're going to see what that is. So if this is x plus 3, right, you know that the equation is a over x minus p plus q. So what is actually the value of your vertical asymptote? Think about that. That's going to be negative 3, because if you want to put it in that same way, the only way you can actually do that is by saying x minus negative 3. That's why when they simplified it, it became x plus 3, because this is your vertical asymptote. This is the negative 3. Okay, that's the value of p. You take that value. So it means that we have an x is equal to negative 3 over here. And this is the only place that the graph will not cross. Okay, the only x values will not cross. So your domain, and what we say that is we say its x is an element of all real numbers. It will have every single x value that is on the number line, but x will not be equal to negative 3. And that's how it is. Simple like that. Okay, 4.2 says, write down the range of h. So let's go ahead and put h in blue. It's the same situation. You see, we have this again. We're thinking about the range of a hyperbola. It will have every single y value as well. Every y value would be present. The only y value it will not have would be the q, which is really your horizontal asymptote. Okay, so it will not have that. That's the only one it will not have. So there's going to be, here it's positive 2. You're going to have a y equals positive 2. And this is the only place that the graph will never cross. Okay, that should be a dotted line. So in this case, it would be y is also an element of all real numbers, but y will never be equal to positive 2. Okay, so that is it for those two questions. Okay, moving on to the next question. The next question says, if the graph of g, okay, so g is shifted so that it coincides with the graph of h. The first question is, how many units must the graph be shifted horizontally? So thinking about it as this graph of g is shifted so that it coincides or perfectly fits into the graph of h. When graphs coincide, or when a graph coincides with another graph, it just means that you had that graph originally, and all it did is it moved to the point that it actually fit perfectly with the other graph. Okay, so it just moves nicely and then gets to a point that it actually sits on the other graph. Okay, so that's what's going on there. So we have to think about how this is going to affect the shift. How are we going to shift them so that this can happen? Okay, so to explain this, I'm going to go ahead and draw a little graph. Now, I need you to understand that you do not need a drawing of the graph for you to do this. If you know how the graphs work and how shifts work, you can actually do this without any drawing. I'm just going to put a drawing so that it makes more sense. So if you have the graph, so we just have our Cartesian plane, and let's just put down our graphs. Now, how we're going to draw the graphs is going to be a very brief and simple graph. I'm not going to think about x-intercepts and y-intercepts really. How we can think about these graphs are, because we already know their asymptotes. So the graph of G, I'm going to draw in red, and this one I'll draw in blue. So with this graph, you know that it has an asymptote at x equals -3, right? It has a vertical asymptote. So I can mark that here. So at x equals -3, we have a vertical asymptote. And then we have a horizontal asymptote here. See, because that is our Q value, or our horizontal asymptote value, okay, at y equals -3/2. So that would be y equals -3/2 on the y-axis, and this is our asymptote, okay? Now, because our graph has a positive a value, okay, it's going to lie in the first and the third quadrant, but it needs to lie in a way that it perfectly fits with its asymptotes. So this is how it's going to be drawn. The graph is actually coming from being really close to the asymptote, and then it goes like that. See, and then goes really close to the asymptote, but never touches it. So that's what your graph is going to look like, roughly. Okay, it may not look exactly like that, or like past the origin, but it looks something like that. And then the other wing is also going to do the same thing, just in the third quadrant instead. So it's going to look something like that. And then the blue graph, right? Because that's going to be what shifts. The blue graph is going to look like this. Again, it's also in the first and the third quadrant. But here your asymptote is what? Since you have an x -3, your asymptote is actually x equals 3, because that is the value of p. See, x minus 3. So we have a 3 there. So we have a vertical asymptote of x equals 3 and a horizontal asymptote of y equals 2. So that goes over here. We have y equals 2 over here. So our graph, again, it's going to be in the first and the third quadrant. So it's going to look like this and like this. See, it goes closer to its asymptotes. That's really what's going on. So like I said, you don't have to draw the graph to understand this. If you understood how these things just move, you could have done this without the graph. I'm only showing you a graph so that you can understand what's going on. So what's going on here is the graph is going to be shifted so that it coincides with the graph of H. So this is very important for you to understand that it's the graph of G that is moving so that it perfectly fits with the graph of H. So how that will happen is like this. What you can use to control the shift of this red graph, the graph of G, is the asymptotes. So what's going to happen is the graph is going to shift. The vertical asymptote is going to shift until it aligns with the vertical asymptote of the graph of H. So in other words, what we're saying is that this graph, right, this line here, this vertical asymptote, it is going to move until it lies perfectly with this one. So how many units should it move for that to happen? Okay, and that's actually the first one they're asking for. They're asking, how should it be shifted horizontally? Horizontal shifts happen like this, left and right. Vertical shifts are up and down. So how should it be shifted so that it perfectly fits like that? Well, from -3 to 3, you moved how many units? You moved 6 units to the right, okay? You can think about it like this. If you wanted to know how far it shifted, you're really just saying, we're going from here to here. What is the distance between them? And to find the distance between points, you take the highest minus the lowest. If you said 3 minus -3, you would get +6. Okay, so that's what happens there. So you need to move it 6 units to the right. That's how we have to shift it. Okay, and if that shifts there, then there we go. It has been shifted to that line. Okay, then this one, how many units must you shift that vertically? So how much units must you shift the graph vertically? Well, that would be, what will control that would be your horizontal asymptote. So this, because this line, for it to shift, it can only move up and down. It can't move to the side. If it moves side to side, it's not going to change. It's still going to pass -3/2. Nothing's going to happen. So you know here that the horizontal asymptote on the graph of H is 2. Okay, so for that to happen, for this to shift from here all the way to 2, you need to have moved the graph how? Well, you could literally count them, but you could also just say, we just need to find this little distance here. That will be the amount of units you needed to shift this graph, and we can clearly see that it's moving up, right? So you could just say highest minus lowest. So what is 2 minus this number, which is -3/2? So that becomes a plus. So that's really 2 plus 3/2. And if you add that, well, adding mixed fractions, you can just multiply this, the whole number, and the denominator, which is 4, and then add 3. So that is 7/2. That's how much units you need to move it. It's 7 units, 7/2 units up. That's how you have to move that. So that over there, the answer is 7/2 units up. And once those asymptotes move, the graph itself will also move and perfectly align with that graph. Okay, so that's really what's going on there. Okay, so that is the answer for that. And moving on to the next questions. Okay, the next question, 4.4, says, write down the equation of the asymptotes of G. So the graph of G, the equations of the asymptotes. Okay, we already had one of it here. So the equation of the vertical asymptote is that x is equal to -3. And the equation of the horizontal asymptote, that Q value, okay, is y is equal to whatever that Q value is. I've already explained it with the domain and the range story. Okay, so that is y is equal to the number here, which is -3/2. Okay, so that is for 1 mark. And then moving on to the next question, that should be up here. I'll just rewrite it up there. Okay, so moving on to the next question, 4.5 says, calculate the x-intercept of G. So what's the x-intercept of G? Well, to find the x-intercept, you just have to make y equal to 0. Since this says g of x is equal to all of this, the g of x is your y, okay? So we're really making that equal to 0. So we're saying 0 is equal to the 6/x plus 3 minus 3/2, and we just have to simplify this. Okay, so to simplify this, because this is negative, I'm just going to go ahead and take it over. When I take it over, it becomes positive. 3/2 is equal to 6/x plus 3. Then you need to solve for x. The best way to solve for x here, since they're both fractions, would just be to cross multiply. So I'm saying 3 multiplied by this. But remember that when you're multiplying the 3 by something that has 2 terms, the 3 needs to multiply into the x and into the 3. So 3 times x is 3x, and 3 times 3 is positive 9, is equal to, and we also cross multiply here. 2 times 6 is 12. And then just simplify. So 3x is equal to, we're going to say 12 minus 9, which gives us 3. And then divide both sides by 3 to solve for x. Therefore, x is equal to 1. And so our intercept, our x-intercept as a coordinate is 1 and 0. X value is 1, y value is 0. Okay, so that is the x-intercept of G. Moving on to the next question. Then 4.6 says, sketch the graph of G in your answer book. Clearly show all asymptotes and intercepts with the axes. So we already have most of the work done for us. In fact, the only thing we have to actually find in G, because you see that in G of x, we just found the x-intercept. The only thing we have to find is the y-intercept, okay? So the y-intercept, when you're trying to find that here, you just need to make x equal to 0, okay? Because that's how you find the y-intercept. So we can just go ahead and do that since we don't have that yet. So that was g of x is equal to 6/x plus 3 minus 3/2. And you're just going to find the y-intercept of this graph. So make x equal to 0. G of 0 is equal to 6 over, and we're going to say 0 plus 3 minus 3/2. Okay, so 6, and we have 0 plus 3, which is 3. 6/3 is 2. So it's 2 minus 3/2. Okay, so that would give you a half. Okay, you can calculate it on the calculator as well, because that is 1.5. So a half. Okay, so we have our y-intercept, and now we can go ahead and actually sketch the graph. We have everything we need to sketch the graph. So we have our axes. We're not really going to focus too much on putting too much points. Just put the important points. That's really all you need. The first thing that we need to put down are our asymptotes. Okay, you need to put down your asymptotes first. So with your G graph, you see that the vertical asymptote is x is equal to -3. So the x equals -3 because the vertical asymptote is a vertical line. It's going to go like that, So we're going to say x equals -3. You don't even have to do that. You can just write -3 here. So they know, okay, that is the line that passes -3 on the x-axis. And then you need the horizontal asymptote, which we know is -3/2. And that's going to be down here. So it's -1 and then halfway through. So -3/2 is here. Okay, -3/2. And I'm just going to put the number there, -3/2, so they know it passes there. Then we have to draw our intercepts. So we have an x-intercept of 1 and 0. So that is, we have 1 and 0. So that's here. And you can just write the number 1. You don't have to write the coordinates. It passes through 1. And then the y-intercept, of course, is a half. So that is on the y-axis. And that is a half. So it's not even past there. It's just a half. Okay, then you have to draw your graph. Remember that your graph of G, the value of A is 6, which is a value greater than 0. When your value of A is greater than 0, your graphs are going to lie in the first and the third quadrant. So now you're just going to join your graph. Your graph is going to go like this. It's going to pass the y-intercept, the x-intercept, and then just move closer and closer to the asymptote, but never touch it. So like that. And then we're also going to just do the same thing on this side. You don't necessarily need a point. What you can just do is kind of estimate the distance between where the asymptotes meet and the line, and then kind of roughly just also measure that here, and then just make sure your graph passes like that. So just like that, and it's fine like that. Okay, so that is your graph of G. Okay, so all the important things are here. This is for 3 marks. So they're just really going to give you a mark for the things, the important points that you have included. That's our y-axis, that is our x-axis. Okay, moving on to the next question. Okay, we're on 4.7 and it says determine the value of k, and there's k here, okay, if h of x is equal to -x plus k, right? If this is an axis of symmetry of the graph of G. So they're saying that this is an axis of symmetry of the graph of G, and you have to just find the value of k. I feel like they should have just called this something else instead of h of x, you know, because we already have a graph called h of x. It's just a little confusing. So anyways, we're going to have to find the value of k. So in a nutshell, what they're saying is we have the axis of symmetry of G, okay? And that has an equation. Let me already speak about that. The axis of symmetry of a graph, right? There are 2 axes of symmetry in a hyperbola. There's the one with a positive gradient, and its equation is y is equal to positive x minus p plus q. And it's easy to remember this if you remember the general form of a hyperbola. See, x minus p plus q. So kind of like repeats there. So the axis of symmetry is really just any line that divides the graph into 2 symmetrical parts, okay? So this part looks exactly the same as that part, and that part looks exactly the same as that part. But we also have another axis of symmetry, the one with a negative gradient, because you see here, this graph would look exactly the same as that graph. And that's why this is a line of symmetry. And the equation of it is y is equal to -x plus p plus q, okay? How you get that is, if you remember this one, you remember that one. Because all that is done to get this graph is they put a negative in front of the x minus p. So we just have this, they put a negative here. And if you distribute, you see that you're going to end up with this. Okay, so now they're really helping you a lot here. They said determine the value of k. If h of x is equal to -x plus k, if that is the axis of symmetry of G. So if this is the axis of symmetry of G, which one is it exactly? Is it this one with the positive gradient or the one with the negative gradient? It would be the one with the negative gradient, because you see that you have a negative x over there. So they're really just saying find this equation and then tell us exactly what k is. K is just everything without the x. So that plus p plus q. That's really what all that is. Okay, so I'm going to say y is equal to -x plus p plus q, and I'm going to take the p and the q value of that and add it into the equation. So we're looking at the graph of G. The graph of G, its p and q value are these. As you can see, the p value, like we spoke about, is -3. That's p. And the q value is this over here, which is -3/2. Okay, so -3 and -3/2, that's all we're adding there. So y equals -x plus -3, which is just minus 3, plus negative 3 over 2, which is just minus 3 over 2. So y equals negative x, and then you're just going to have to simplify that. Okay, that's like saying 3 plus 3 over 2. You multiply those, that gives you 6 plus 3, which is 9. So that's going to be 9 over 2. But it's negative, okay, because it's negative minus that. So that's negative 9 over 2. You can also use a calculator. So we can finally tell them that you see the value of k. K is that negative 9 over 2. So therefore k equals negative 9 over 2. And that is our answer. Okay, moving on to the next question. Then in the next question, 4.8 says, for which value or values of x will 6 over, and as you can see, that is the graph of g they're giving you there. Okay, that's the graph of g is greater than negative x plus k. We just saw this graph. This is your axis of symmetry, the one with the negative gradient. Okay, that h of x graph, which I really feel like they shouldn't have called h of x, but okay. So that's really what we're looking at. So you can use the graph to think about how this works, but if you visualize the way a hyperbola and its asymptote looks, you'll be able to already see what's going on there. I'm going to use the graph. It's better to use the graph here. So we're going to look at the graph of g, and you're going to look for where it is greater than the graph of h, your axis of symmetry. In other words, you're looking for where this graph is going to lie above that axis of symmetry. That's really what you're doing, because if it is greater is referring to the y values of this graph. So if we draw that is our graph of g. There's our graph of g here, right? And if we're looking at that axis of symmetry, that graph that I said is called h of x, that would just be a line, really a dotted line. It's a diagonal dotted line that is going to pass through this point over here, and this point is the intersection of your vertical and your horizontal asymptote. That is where that line is going to pass. That h, which is y, or let me just call it h of x, equals negative x minus 9 over 2. Okay, that's where that's going to pass through. So the question is, where is g of x going to be greater than h of x? That's really all they're asking you. Now, the only place where the graph of g is going to be above the graph of h is here, this part of the graph. Because if you go anything beyond this, if you take this part of the graph, do you see that everything here, or this graph, is lower than this line? Okay, that's really what we're looking at. This graph is lower than this line. And so we cannot take that because all its y values are going to be below that. Like if you are comparing it to the same x value. This is what I mean by that. So what I mean by that is, let's look at it like this. Okay, you see, for example, see this point over here? Its y value is negative whatever that number is, right? Now, we have to look at this graph's y value for this same x value. So the x value we're referring to is something here. And if you're looking for this graph's y value for this same x value, look at where that is. Do you see that the blue graph's y value is higher than the red graph's y value for the same x value? That's why I'm saying that the only place that you will find that this graph is above this axis of symmetry would be here and nothing here, because this is really just below this. We're really just looking at it like that. That is just below this line. So we need to write the values of x for which this will happen. Okay, so you already see that you have an asymptote here. So this graph will never pass this line, meaning it starts from -3, or really values that are greater than -3. And then it continues until this graph goes on till infinity like that. So this is from -3. This is where x is. As you can see, it's moving towards the right-hand side. It's every value that is greater than -3. And it just keeps going because this line will just keep getting closer and closer to the asymptote, but it will never pass the asymptote. Okay, so it's really just every part of that wing of the graph. So it's where x is greater than -3. That's our answer there. So the answer for this is where x is greater than -3. Okay, moving on to the next question. Okay, then the last question for question 4 says, the graph of g is reflected in the x-axis. Write down the new equation in the form of y is equal to. So remember, if something is reflected in the x-axis, this is an x-axis, okay? If something gets reflected in the x-axis, what it causes is, just look at it like a point. Let's say this point was 1 and 1, right? If it gets reflected in the x-axis, so it now appears here, what's going to happen is your x value stays exactly the same, but your y value would change. So because it's reflected as a mirror image, it's really just going to go the same distance, okay? So it's going to appear at -1, so 1 and -1. So if a graph is reflected in the x-axis, it causes the y values to change their signs, okay? In other words, you really just multiply the y values by -1. So that's what we're going to do. We're going to take the graph of G and multiply its y values by -1 so that we can reflect it in the x-axis. Okay, so our graph of G said G of x is equal to, and it was that, right? Is the 6 over x plus 3 minus 3 over 2. And this gets reflected in the x-axis. So we're going to take the y values and multiply it by -1. It's like taking G of x and multiplying it by -1. So we have negative G of x, okay? And so what happens there is you're saying negative G of x. This was what G of x was equal to. What happens is we have a negative being multiplied into it. So it's going to really appear in front of it like that. So we have negative 6 over x plus 3 minus 3 over 2. And then you can just distribute this. So if you distribute, that now becomes a negative 6 over x plus 3. And then that becomes, when it multiplies, positive 3 over 2. If you like, you can actually, and it should be written like this actually. It should be written as, you can put the negative in the middle just to show you that the fraction is now negative. So we have 6 over x plus 3 over 2. That is going to be your new graph. And they did say we're going to call it y is equal to. So that is our new graph. Y equals that. Okay, so that is it for question 4. Now we move on to question 5. We are on question 5, and question 5 says the graphs of f of x is equal to negative, and then we have x minus 7 over 2 all squared plus 81 over 4. So looking at that graph of f, can you see that it is raised to the power of 2, right? Meaning the highest exponent of x is going to be 2, meaning this is a parabola, right? And this parabola is in turning point form. Okay, so that's going to be very helpful here. And g of x is equal to negative 3x plus 24 are sketched below. Okay, so we have those two graphs. And they tell us that the graph of f and g intersect at points D and B. And we have points A and B are x-intercepts of our graph of f, our parabola. The first question is to write down the coordinates of E, the turning point of f. Okay, so they're making it very clear. That is your turning point. So we are at an advantage here because they gave us this parabola in turning point form. And turning point form is y equals, and we have a multiplied by x minus p all squared plus q. So you see the value of p and q, that would be the coordinates of your turning point. Please notice that this says x minus p, right? But we have a positive p here. So you see x minus, and you have 7 over 2. So 7 over 2 is your p value. And then q is just plus q. So 81 over 4 is your q value there. So our coordinates of p will be those two. So E is going to be the 7 over 2 and that 81 over 4. That is going to be the coordinates of our turning point. And I'm also just going to include it here as well. Okay, moving on to the next question. The next question, 5.2, says, determine the average gradient of the curve of f between x is equal to 1 and x is equal to 5. So they just want you to find the gradient of this curve, of the graph, right, at these points. So they gave you the x values of the points. Remember, average gradient, the formula for finding the gradient of 2 points, because that's really what they're asking you for. The gradient of 2 points, the formula for that is y2 minus y1 over x2 minus x1. So we're going to use this here. But in order to do that, we need our y2 and our y1. You see that they only gave us the x values. So you can call that your x2 and that's your x1, right? we need to find the y values of those. So to find the y values, you can substitute your x values into your equation and it will give you the y values. So we're going to go ahead and find out what exactly f of 5 is, because that's going to be our y2. And we're going to use our formula. So let me rewrite that down here first. Okay, and in place of x, you're going to substitute 5. So that's what we're going to do there. Okay, so let's go ahead and find out what exactly this would give us. And that gives us 18. So we know that f of 5 is 18. And it's important to substitute because they want to actually see, they probably want to see that substitution. Then again, you are getting a mark for the answer. If you got the answer, they know you substituted. Okay, and then we also need to find f of 1. So we're going to, in place of x, put 1. And you see there that f of 1 is 14. I don't really think you need to show them the substitution, but we can, it's fine. So I just copy that, and in place of 5, I'm just going to put 1. And we know that the answer of that is 14, like we saw on the calculator. We have 14 there. So that gives us 14. So to find the average gradient, we are using the gradient formula, okay, which is this. And so let me just pull this down here. So we are using this. So to find that gradient, okay, do those points have names, 1 and 5? Well, not really. Okay, so they don't really have names, so it's fine. I'm going to go ahead and call that. That's going to be, so y2, remember, since this is our x2, this is our y2, so that's the 18. So that's going to be, well, let me write it like this, first of all. So we're saying that in place of that y2, it's going to be our f of 5, since the x value is our x2, minus our f of 1, right? That's y2 minus y1, over x2 minus x1. Our x2 is 5, and our x1 is 1. Okay, so substituting, that's really just the 18 minus 14, 18 minus 14, over 4. 5 minus 1 is already 4. So 18 minus 14 is 4. 4 divided by 4 is 1. So our answer here is just 1. That is going to be our average gradient. Okay, moving on to the next question. The next question, 5.3, says, calculate the value of A, the x coordinate of point D. Okay, so they want us to find the value of A, which is the x value of this point. You remember what they told you about this point D? They told us that the graph of F and G intersect at points D and B. So it's a point of intersection. So to find out what exactly that x value is, right, you're just going to have to make the graph of, since it's the place where f and g meet, it's the place where f of x is exactly the same as g of x. We're saying their y values are the same and their x values are the same. So we're going to have to equate the graphs at that point. So that's what we're just going to do. We're going to tell them that f of x should be equal to g of x. And f of x was that. Just substitute x in place of that there. And this should be equal to g of x, which they told us at the beginning of this. So that is negative 3x plus 24. So minus 3x plus 24. And we just have to simplify now, solve for x. Okay, so normally I'd like to leave these two alone and just try to simplify and get to the x. But there's no use of doing that right now because we already have an x here. So you might as well distribute here. Okay, so we can go ahead and distribute this. Okay, what I can do actually is take this over. Since it has a negative in front of it, I'll take it over and make it positive. So we're going to have here positive x minus 7 over 2 squared, right? And then I'll just take everything over here. So leave nothing on this side. Here on the right hand side, we still have the minus 3x, and then we have the plus 24, and then this positive 81 over 4 that is on the left hand side will come over and become a negative 81 over 4. Okay, so we're just going to have to simplify this part now. 0 is equal to, so you see that you have a binomial squared. You can go ahead and create two brackets and distribute. That will take too long. You can actually just do this this way. So you square the first term, that is x squared. You can go ahead and square the last term. So that becomes a positive because it's negative here. And 7 squared is 49, 4 squared is 4. Then you're going to say first term multiplied by second term. And you see that that's going to give you negative 7 over 2x. Then you multiply that by 2. Okay, you see that 2 is a number that's actually on the numerator. So what's going to happen is it's going to cancel with the denominator here, and you'll be left with negative 7x in the middle. Negative 7x is in the middle. Okay, so it's square the first term, square the last term, multiply the first and the second term, and then multiply it by 2. Okay, then we have minus 3x, and then the numbers, we can actually just simplify that. So what is 24 minus 81 over 4? That's what we have to simplify there. Okay, so what is 24 minus 81 over 4? Well, you can actually just use a calculator, but you can write 24 as 96 over 4. I'm trying to make the fractions to be equivalent, so make the denominators the same. And we have minus 81 over 4. 96 minus 81, that is the 9 minus the 8 is 1, 6 minus 1 is 5. So 15 over 4 is what we're going to have there. So positive 15 over 4, sorry, 4, not 14. Okay, so this is what we have. And just simplify. You see that you have x and x that can go together here. So that 0 is equal to x squared. What is negative 7x minus 3x? That will be negative 10x. And then we have 49 plus 15. If you have 49 and 15, you can go ahead and add that together. So that's just going to be your 14 and then 64. So that's going to be positive 64 over 4 because the denominators are the same. But then 64 can divide by 4. See, so 64 divided by 4, it's like dividing by 2 and then dividing by 2 again. So that's 32 divided by 2 again is 16. So that just gives you a positive 16. Okay, so we have a trinomial right now. Okay, and we can go ahead and factorize this trinomial. So 0 is equal to, open up 2 brackets, and we have x multiplied by x. And factors, we need factors of 16 that can give us 10. So factors of 16 can be 1 and 16, which will definitely not work. It can be 2 and 8, which looks perfect, okay? Because the middle is negative, right? The only way you could have gotten this, and you can see that this is positive, okay? The only 2 things that can multiply that can make that positive, but that stay negative, is if this is negative 2 and negative 8, because negative 2 times negative 8 is positive 16, but minus 2 minus 8 is negative 10. So that is going to be minus 2 minus 8, and then just solve for x. So therefore, it means that x is either equal to positive 2 or x is equal to positive 8. So you have 2 answers here, and you need to choose the one that is for A, the x coordinate of point D. Okay, so remember, this is positive 2, positive 8. So one is bigger than the other. Which one is A going to be? Because A is more on the left-hand side, this is the 2. Then this one is the 8. Okay, so we can go ahead and tell them that A finally is equal to 2. So therefore, A is equal to 2, and that is our answer. Okay, moving on to the next question. Okay, 5.2 says, point S is a point on the graph of f where x is greater than a. We already know what a is, it's 2. So x is greater than or equal to 2, but less than or equal to 8. And then they tell us that line ST is drawn parallel to the y-axis. We already have this. So let me just bring down the graph so that we can actually look at this properly. Okay, so what they're telling us is that we have this point S, okay, which is here. And it's a point on the graph where x is greater than or equal to 2, but less than 8. As you can see, that is true because we already found the value of a to be 2, right? So that x value is over here. That is 2. And we know that this x value is 8. So indeed, that point S is sitting, its x value is sitting where x is greater than 2, but less than 8, okay? It's in between this. That's really what they're trying to tell you. Okay, and then what else did they tell us? They said line ST, that line ST, right, is drawn parallel to the y-axis. So all it is a vertical line, okay? Parallel to the y-axis with a point T on the graph of G. So you see that S is on the graph of F and T is on the point on the graph of G, right? And you need to determine ST in terms of S. So you have to determine the distance of this line in terms of X. Because they didn't give you X and Y values, that's what we're going to have to do. So in order for us to actually do this, think about how you calculate the distance of a line, because ST is really speaking about the length of ST. So the distance of a line is calculated by taking the highest y value, I'll call that y2, right, minus the lowest y value, y1. But in this case, they didn't give us y values. The only thing they told us is that S is clearly on the graph of F, right, the parabola, and T is on the graph of G, the straight line. So the only way to find it is by using the y values of this graph. But that's actually using the function of it, because think about it, the y value of this graph F, right, we can express that as f of x. And the y value of G can be expressed as g of x. So to find the distance, because this lies on F, its y value, we can call that f of x. And because that lies on G, we're going to call that g of x. That y value is called g of x. So to find the distance, to say, you have to say that y2 minus the y1 to get exactly what the distance is. So we're going to say that f of x minus g of x, and that's going to give us our distance in terms of x. So f of x minus g of x, and then you just simplify that. So we know that f of x is this and g of x is that. So I'm just going to go ahead and write them down, and we're subtracting. Okay, so this is f of x, this is g of x, but you're subtracting, okay? G of x already has a negative in front of it. So if you're subtracting, you're going to have to protect this with brackets, okay? So that's what we're doing here. So it's equal to this, and we just have to simplify this really. You can actually just use the simplified expressions of when we were equating these two graphs. So when we're saying f of x is equal to g of x. Okay, so with this part, we already kind of worked on that. We know what this is going to give us inside the bracket, right? Because when we simplified the inside of the bracket, it ended up becoming this. So I'm just going to rewrite that. And then, of course, I know I have a negative in front of it. Okay, so we're going to have our negative and then x squared and our minus 7x plus 49 over 4. Okay, so minus 7x plus 49 over 4, and then that is going to distribute in. So if it distributes in, you get a negative x squared plus 7x minus 49 over 4. So that's what actually happens when that little part simplifies. Okay, then of course you have the plus 81 over 4, and then if you distribute here, you get positive 3x and minus 24. Okay. And this is equal to, we have negative x squared, and those two add and become positive 10x. And then all of these numbers really just simplify together. As you can see, if we simplify the constants, you're just going to get negative 16. So minus 16. Okay, so there we go. That is our answer there, and that is for 2 marks. So they'll really just give you a mark for actually forming your equation and then your answer. Okay. Moving on to the last question in question 5. Okay, last question 5.5 says, calculate the maximum length of ST. So in the previous question, we found the distance of ST, really, right? We found the distance of ST in terms of x. So since we have that distance, we can now use it to find the maximum distance. It's really the length of ST that we have. So we can now find the maximum length of it. Okay, so we know that ST is equal to negative x squared plus 10x minus 16. To find its maximum length, okay, to find the maximum or minimum, we are going to derive this function, okay? And remember, the idea behind that is this right now is a parabola. It's a concave down parabola. And to find the maximum length, or really the maximum of this parabola, that would be the highest points that it can reach. That is your maximum. So to find that, because this is your maximum point, it's also the turning point. So you're really just finding the turning point's y value of this graph, okay? To find the turning point's y value, there's 2 ways. You can either derive or you can use the equation for turning point, which is x is equal to negative b over 2a. Okay, so let's go ahead and find that. So we're going to derive this. I'll say st prime is equal to, and let's derive. So we're going to say coefficient times exponent, which gives us the negative 2x, and then that exponent minus 1, which is 1, and you don't have to rewrite that. Then this becomes 10 times 1, which is positive 10, and the exponent of 1, you subtract with a 1, which becomes 0, and anything to the power of 0 is 1. 1 times anything stays the same. So this is what we have, right? Then to find the turning point, that actual turning point, you're going to make your derivative, right, equal to 0. In other words, the derivative is the gradient of the function. You're making the gradient equal to 0 because at any turning point, the gradient is equal to 0. Since this is the place where the graph is no longer increasing nor decreasing. All through here, what the graph is doing here, if you look at it from left to right, this graph is increasing. It's moving up and moving up. And so the gradient you're going to find here would be positive because the gradient shows you whether the graph is increasing or decreasing. Positive gradients are increasing, negative gradients are decreasing. But at the turning point, the gradient stops doing that and it stands still. That's why the gradient is equal to 0. And that's why we make the derivative equal to 0. Okay, so now that we know that, we're going to go ahead and say 0 equals negative 2x plus 10. And then I can just go ahead and take the negative 2x over to make it positive, divide both sides by 2, and x is equal to 5. Now, what we just found right now, and I keep erasing that diagram, it's actually helpful. What we just found right now is the x value of that turning point. You still have to find its y value. So to find its y value, you can take the x value and substitute it into the original function, okay, of this concave down parabola, which is this. That is the original function. That is the equation of st, the length of st. So we can do that and say that st, we're substituting where x is equal to 5, is going to be negative, and we have 5 all squared plus 10 times 5 minus 16. And that will give you your maximum. So let's go ahead and find that. And our answer for st, the maximum, is 9. Okay, so we can go ahead and tell them that the maximum length, okay, of st is 5. Okay, so that is that question, and we are done with question 5. We finally move on to question 6, which is the last part of functions for this paper. We are on question 6, and question 6 says the graph of f of x is equal to 3 to the power of x is sketched below. So as you can see, this is an exponential function, and there's something here that I know we cannot see but is there. Okay, please remember that this exponential function, it usually has a q value, okay? But because we can't see the q value, please note that that q value is equal to 0. Your q, okay, in your exponential function, a times b to the power of x minus p plus q, that is your horizontal asymptote, okay? So because it's your horizontal asymptote, it's the line, the horizontal line that this graph will never touch, okay? And we also have a point which is p, -1, and 1 over 3 is a point on this graph f. So please just remember that we have that over there. That q value is 0, okay? That horizontal asymptote, because it's a horizontal line, its equation is y equals 0. Horizontal lines always start with y equals, because it's really just a line passing a value on the y-axis, okay? So this is what we have. And the first question, 6.1, is to write the inverse of f in the form of y is equal to. So to write the inverse, because this is the original function, we can go ahead and write it in terms of y first of all. So it's y equals 3 to the power of x. Then to find the inverse of it, you swap x and y. So it's x equals 3 to the power of y. And then to simplify or solve for y, you're really just going to make y the subject. The only way to make y, or the exponent, the subject, is by using log. So we say y is equal to log of our base, and then we have x here. Okay, so that is the equation that they're asking for, the equation of the inverse of f in the form of y equals. So moving on to the next question. The next question, 6.2, says sketch the graph of y equals, as you can see, this is the inverse. So sketch the inverse of f and the inverse where we have x minus 2 on the same set of axes in your answer book clearly indicate or intercept with the axes. So let's understand what happened here. We know that this is the inverse, right? That is the inverse. And this is also the inverse, but something happened here. They said x minus 2. Remember, when you add a subtract to the x, you're really just moving this graph horizontally, which is left or right. When it is a plus, it's moving to the left. And when it is a minus, it is moving to the right. So this graph is actually moving 2 units to the right. So it is the inverse, but it's moved 2 units to the right. So we have to sketch this one first, then we'll be able to understand how this one looks. Okay, so let's go ahead and put our axes down. Now, sketching the inverse function is actually really simple. And the reason I say so is because, remember when we were finding the equation of this, what was the first thing we did? We swapped x and y. Okay, swap x and y. So because of that, really what happens to the function is all the x and y values of the function just get swapped. Okay, so if your graph initially looked like this, right, then the new graph is going to do this. You see, the x and y value, we have 1 point on this graph and we can use that. The x and y value are going to swap. So we're not going to have -1 and 1/3. We're going to have 1/3 and -1 as our new point of P. Okay, the image of P. So let's go ahead and put that down. Okay, so along with the x and y values swapping in this function, right, to get the inverse, what's going to also happen is the asymptotes are also going to swap as well. You see that here we had a horizontal asymptote of y equals 0. Now, in our inverse, we're going to have a vertical asymptote. And instead of it being y, because it's vertical, it's going to be x equals 0. Okay, so that's the first thing I want to let us know, that we're going to have an asymptote over there. Okay, so I'm going to actually write the equation. We have x equals 0 over here, and then the graph really just swaps. So the points that you have P, instead of it being -1 and 1/3, the x and y value will just swap. So you have 1/3 and -1. That's what you're going to have as your image of P in your new graph. So here, 1/3 and 1. So let me just put down some coordinates just so that there's a bit of order here. Okay, so you see what our original function did. Our original function, what it was doing is it was increasing, but it was coming from the negative part of the x-axis. And then as it moved towards the positive part of the x-axis, what it started doing was it started increasing. Okay, so we're looking at it as the y values were going from the, not really negative, but a lower part of the y-axis, and then the y values basically just started to increase. So this is going to do the exact same thing, but it's just going to do the other way around. We'll first have to plot that point down. So -1 and 1/3 becomes 1/3 and -1 here. So 1/3 is somewhere here, right? And then -1. So this is our new point of P over here. And we can just put it as P prime, the image of P. So that is 1/3 and -1. And then our graph is going to do this instead of it doing this. So you can actually just imagine it like this. The easiest way to do this is, you see your x-axis, treat it as if it's your y-axis. And your y-axis, treat it as if it's your x-axis. So when we're looking at this part, you see the negative part of your x-axis, you're going to now focus on the negative part of your y-axis. So that would be here, right? And it means that your graph is going to be really close to the negative part of your y-axis as it is close to the negative part of the x-axis here. See, it's coming from being really close to that, and then it starts to increase. So that's what we're doing here. It's coming from here like this, and then it starts to increase, okay, as it moves towards the positive part of the y-axis. And here is as it moves towards the positive part of the x-axis. That's really what it's doing. It's doing that. So over here, you're going to just treat your y-axis like it's your x-axis, and that's exactly what it's doing. But it's going to pass that point P. That's the only difference. So we're going to have it doing something like this, pass the point P and go up. And there we go. So that is our graph. That is the f-1. That is the inverse, first of all. I'll just call it f-1 of x so that just we'll know exactly what this one is. Okay, so now that we have this graph sketched, I feel like having the x-intercept will be very helpful here because it might be useful. So you can find that. Well, the x-intercept is not a difficult thing because here, this is what you're going to think about. You see Q here? That's your y-intercept. Now, there's something you would have noticed by now. When you have an exponential function, when you see the value of p here is still 0. So if your value of p is still 0, and you still have this over here, the q value is still equal to 0, then naturally your y-intercept is always going to happen at 1. Okay, that is really just because to find the y-intercept, you make x equal to 0. 3 to the power of 0 is 1. Okay, so that's what we know. So if the y-intercept as a coordinate is 0 and 1, and you have your inverse function and it swaps places, okay, the x and y swap places, then it means that the new points you will have on your inverse would be 1 and 0, which is an x-intercept. See, we didn't need much calculation. Okay, so we know that the x-intercept is supposed to happen at 1. So I'll just try to draw it again, just let it pass 1. Okay, so like that, I had to just redraw the graph, okay, so that it passes 1 and still that 1 over 3 and negative 1. Okay, so that is what our inverse function looks like. That is the f negative 1 of x, right? Then we have to draw this one, okay? The inverse that is shifted 2 units to the right. So all you're going to do is take this graph and you're going to shift it 2 units to the right. So because it's moving to the right, this is a horizontal movement and it's affecting the x. It means all the x values of this graph are going to all move 2 units to the right. So what happens here is, remember that we had an asymptote here, right? We already wrote that asymptote. It was x is equal to 0, right? That line there. It's going to also move 2 units to the right. So that asymptote moves from 0, 2 units to the right, it moves to 2. So now your new asymptote there, I'm actually just write it like this in green. Your new asymptote there is a line that's going to pass 2. So there we go. And it's going to be a dotted line. So let me just make that dotted. And the equation of it, instead of it being x equals 0, it's x equals 2. Okay, so that's the first thing that we have. Then you see that we have this point 1 and 0, the x-intercept. That's going to move 2 units to the right. So 1, 2, it now appears at 3. So that's going to be over there. That's the new x-intercept of this graph, right? This graph is green. And then we also have this point, of course, it's 1 over 3 and negative 1. So it's moving to the right, okay? So only the x value is going to change. It's moving to the right by 2 units. Okay, so that's like 1 over 3 plus 2, which is really just, okay, so that's going to give you 2 times 3 is 6 plus 1 is 7. So that's 7 over 3. And 7 over 3 is about 2.3 recurring, right? Okay, so that is just past 2 and 0.3 recurring. So it's just right here, just and a third somewhere here. Okay, so that is our new point there, 7 over 3 and negative 1. Still the same, okay, still the same y value. And so our graph is just going to do the exact same thing. It's just going to do that using this as the asymptote. So it's going to look like that. It's going to be coming from here, increase, and then shoot like that. Okay, so that is your f negative 1, x minus 2. There we go. So these are your 2 graphs, and that's what it's going to look like. It's very important to remember that this has an asymptote. Despite the fact that we may not see it, it is there. Okay, so that's what that looks like. Okay, moving on to the last question in question 6. Okay, 6.3, the last question in question 6 says, use your graphs drawn in question 6.2, so the previous question, to solve for x. If log of base 3, we have x minus 2. So as you can see, this is this function that we have here, right? Because you see that it's the same thing as the inverse. You just have an x minus 2. So that is the green graph, right? So if this is less than 1, so you need to find the values of x for which the green graph has a y value that is less than 1 or has y values less than 1. Let's look at that. So because we're saying less than 1, remember they're referring to the y values. They're just telling you find the places or the values of x where you're going to have all these y values being less than a y value of 1. So your y value of 1 appears here, right? So this is our marker. We need to find all the places on the green graph where its y value is lower than that 1. And as you can see, we can actually see it here. All the places on this graph that has a y value lower than 1 is all through here. So all through here like that, okay? Because there's 1, and then everything below it is less than 1. So everything here. But now we need to be able to express that in terms of x. How do we do that? Remember, you see, the asymptote is something that's going to really help you a lot here. Because there's an asymptote of x equals 2 here, it means that this happens all through here. So values that are here, and they keep going, and where they end at is here, okay, where we have a y value of 1. So the first thing we would have to do is find out exactly what the x value is when our y value is 1, so that we know where to stop. Because we know where it starts. It's when values are greater than 2. But where does it end? Okay, so let's find out exactly where does this graph have a y value of 1. And really all we're doing there is saying, where does it have a y value of 1? You're making 1 equal to that function, the function of the green graph of f of x minus 2, right? Which is this log with the base of 3, and we have x minus 2. So we're really just making it equal to 1. You can write it in exponential format to solve for x. So the base is 3. That would mean the exponent is the 1. And then what it's equal to is x minus 2. So solve for x here. If you take the 2 over, it becomes positive. 3 to the power of 1 is 3. So that's 3 plus 2, which is 5. And so you can see now that x is equal to 5. That this happens at the point where x is equal to 5. My numbering is obviously not too good here. So maybe we have 4, then 5, then 6, okay? So it happens here where x is equal to 5. That's where it stops. So we can see now that the places on this graph that has a y value that is lower than 1 on the green graph, it starts here and then it shoots down like that. But when we're looking at it in terms of x, these are values that are greater than 2 but less than 5, okay? So that's really the only calculation we needed to do here. So we're going to go ahead and tell them this is where x is greater than 2 but less than 5. So one thing that would have really helped you in this is remembering that this has an asymptote because it is a log function. Okay, so that is it for functions of this paper. And in the next video, we will move on to financial maths.